Again, welcome to the lecture series of sequence and series, my dear friends. And yesterday we talked something about monotonically increasing and decreasing when it will be convergent. And today I am going to solve some problem on that. And before that, let's solve one theorem or result like this, whatever you can take. Suppose my sequence is xn and it is convergent to x. That means limit n tends to infinity, xn equal to x. I have to prove that xn plus 1, the limit of this limit of xn plus 1 is x, and limit n tends to infinity xn minus 1 equal to x. It is obvious because suppose this is my sequence, my xn is converging to x, and it has been written that it is a converging sequence, means all terms should converge to x. It will, of course, my xn plus 1, xn minus 1, they will also converge to x, but I have to prove it mathematically. But as you know, I will prove this one, you have to prove this one. Okay. So I have to prove this one. I am boxing this. Okay. So for proving this, what is the first rule? Not rule, what is the first thing we use? Let epsilon is any positive real number. And I am assuming this xn plus 1 equal to yn. It is given xn is converging to x. Can I write xn minus x mod of xn minus x is less than epsilon for some n greater than equal to m. So can I replace here? Means for all n greater than equal to m it is valid. Means I can write x mod of xn minus x is less than epsilon mod of xm plus 1 minus x is less than epsilon, like this. You can continue xm plus 2, xm plus 3. So if my xn plus 1 equal to yn, can I write my x of n equal to y of n minus 1? Similarly, in x of m, I can write y k minus 1 minus x is less than epsilon. Similarly, y k minus x mod is less than epsilon. It will be continue. So from here to here we wrote like this. How we write? Like that we can write here mod of yn minus x is less than epsilon for every n greater than equal to k minus 1. Here k minus 1. So my sequence is convergent. So you can prove this also in the similar fashion. Now I am going to tell something, but I will not prove this. Remember, there is a strong relationship between xn and x. Whatever we will do, they will never break up. Means if my xn and x are you getting, means this one means my if xn is greater than equal to 0, then my x will be greater than equal to 0. If my xn is less than equal to 0, then my x will be less than equal to 0. I am not proving this because these proofs are like 1 plus 2 is how much? Like this proves. So I am not doing this. So let's solve a problem based on whatever we studied yesterday. So let's say my question is given, x1 is like this, x2 is this, x3 is this. You can read from the board now. My xn plus 1 square root of 2 plus xn. I have to prove that my xn is convergent, and also I have to find its limit. For proving this sequence is convergent, I will use the concept that we studied yesterday, and for this finding limit, I will use the concept that we studied just now. See here, my x1 is root 2. Can I say this is less than 2? My x2 is 2 plus root 2. It is also less than 2. In the same fashion, my xn plus 1 is given 2 plus xn. Do you remember mathematical induction? Means what you did in mathematical induction? You proved P1 is true, then you have to assume Pk is true, then you have to prove that Pk plus 1 is true. In the same fashion, I proved x1 is less than 2. Okay. Now I am assuming xn is less than 2. This is I am assuming. So what will my xn plus 1? Can I write it is less than 2 plus 2, because xn is less than 2. It is less than 2. That means my xn plus 1 is less than 2 whenever xn is less than 2. Means it is true for all n greater than equal to 1. Means I can write my xn is less than 2. And see here, whatever value will come, it will come 1.414 square root of 2. If you calculate this, it will be 2 plus something. 2 plus 1.414, 2 point means 3.414 square root. Means it will increasing. In the next, it will again increasing, means it is a monotonically increasing sequence with 2 as its upper bound. Means what I get, my xn is monotonically increasing sequence. My xn is monotonically increasing sequence with 2 as its upper bound. But I don't know whether it is supremum or not. But if I get any monotonically increasing sequence which is bounded above, upper bound means it is bounded above, that means my xn is convergent. So xn is convergent, proved. Now I have to find its limit. Means what is given? Square root of xn plus 1 is this much. Can I write x square n plus 1 equal to 2 plus xn? I am taking limit both sides. Limit n tends to infinity, x square n plus 1 equal to limit n tends to infinity 2 plus xn. Let I am assuming my xn is converging to x, so I can write here x square equal to 2 plus x, here is the bracket. You can find x square minus x minus 2 equal to 0. So what will you get? X minus 2 into x plus 1 equal to 0. So my x is coming 2 and minus 1, but minus 1 can't be possible because it should be converged to its supremum. As you know, 2 is one of its upper bound, minus 1 can't be, so x equal to 2. So limit of the sequence is 2. Understood? Minus 1 can't be the limit of the sequence because every term, the first term is 1.414 and all are increasing. Are you thinking minus 1 will be the limit of the sequence? No. So let's solve something. I hope this example is clear. Now I am doing some limit which we use at many places. Means we know limit n tends to infinity 1 plus 1 by n power n, means this is a sequence. This sequence is convergent. In one class, in first or second class, I told you if limit n tends to infinity an exists, that means my sequence is convergent. If limit exists, it is convergent. I'm trying to prove in this way. And you know this is E. Do you remember how? So I am proving this. Let I am taking y equal to 1 plus 1 by n power n. I am taking logarithm both sides. Ln y equal to n ln 1 plus 1 by n. Why this happened? Because ln x to the power m equal to m into ln x. So I am taking limit both sides. Limit n tends to infinity, and I can write ln either inside or outside, it will be no problem. Equal to limit n tends to infinity ln 1 plus 1 by n, and I am writing n as 1 by n. If you will put n as infinity, you will get 0 by 0 form. Put here ln 1 means 0, this 1 by infinity means 0. If it will come 0 by 0 form, then what we have to do? You have to just differentiate. Just differentiate. If you differentiate this, then you will get 1 by 1 plus 1 by n into minus 1 by n square. This will get minus 1 by n square. And this cancel. If you put n equal to infinity, you will get 1. But you have to find this one. Because why is this one? So limit n tends to infinity. Can I write this in place of y? 1 plus 1 by n power n equal to e to the power 1 means e. Means my limit is existing. That means my sequence is convergent. Okay. Now I am writing something. We'll consider some result. Suppose there is a two sequence an, another sequence bn, and every term of the sequence is less than the corresponding term of this sequence for all n belongs to natural number, and both are convergent. Let an converging to a, bn is converging to b, then a will be less than b. How? That I am proving. As an is less than equal to bn, can I write bn say n is greater than equal to 0? If I take limit both sides, then can I write this limit n tends to infinity bn minus limit n tends to infinity an is greater than equal to 0. That means this is given, it is convergent. B minus a is greater than 0, means my a is less than equal to b. Proved. Understood? See here, what we consider, there is another result. Result number 2. If my a is less than equal to bn less than equal to c, okay, then my a will be less than equal to b less than equal to c. I told you there is a corresponding relationship between bn sequence and its limit. They will never break up. Means if bn is in between a and c, my b will also be in between a and c. Let I am proving another example. Let me do another example. This one I will use the same concept what we studied, monotonically increasing, monotonically decreasing. But see here, it is in the form of something divided by something. If I will do a n plus 1 minus a n for knowing whether it is monotonically increasing or decreasing, means it will be difficult for me. If something is divided in the form of division, means it will be better to take a n plus 1 divided by a n. What is my a n here? My a n is n factorial by n to the power n. What is my a n plus 1? N plus 1 factorial divided by n plus 1 power n plus 1. This will be n factorial by n to the power n. This is cancelled. What will I get? This 1 n plus 1, 1 n plus 1 cancelled. I'll get n by n plus 1 power n. If I divide n both in numerator and denominator, what will I get? This power n. And see, this is 1 plus something, and n is a natural number. See, this whole term will always greater than 1. If we divide 1 by some term greater than 1, it will always less than 1. That means my a n plus 1 is less than a n. Means I can say it is a decreasing sequence or monotonically decreasing sequence. Monotonically decreasing sequence. And if you put anything, will you get ever 0? You may get something above 0. So can I say 0 is one of the lower bound? Because put 1. If you put 1 also, 1 factorial by 1 to the power 1. You will get 1. If you put 2 factorial, then you get 2 factorial by 4. This 1 by 2. It is monotonically decreasing, but it will never decrease beyond 0. So 0 is one of the lower bound. 0 is one of the lower bound. Means a monotonically decreasing or decreasing sequence bounded below is convergent. So my sequence, this sequence is convergent. Now I will find its limit. You understand this is convergent? Let's consider this. Let's consider 1 plus 1 by n power n. Have you remembered this binomial expression? 1 plus x power n equal to nc0 plus nc1 x power 1 nc2 x square, like this, at last ncn x to the power n. So just express its write the expression, binomial expression of this. 1 plus nc1 means n, this is n into 1 by n means I can write 1, n into 1 by n means 1, plus nc2 into 1 by n square, at last I will get ncn into 1 by n to the power n, but I know ncn equal to 1. So I will get this one. This is, so can I write this is greater than 2? Say 2 plus something positive number. That means this whole term is greater than 2. If it is greater than 2, can I write 1 by 1 plus this is less than 1 by 2? Just put here. This is reverse of that one. That means it will be 1 by 2. And what is this? This is an plus 1 by an. Means I can write an plus 1. An plus 1 is greater than equal to 2. It may be 0. If very less, then it may be equal to 2. Na? If this whole part something will come 0.00001. It's greater than equal to 2. So it is less than equal to 1 by 2. I can write an plus 1 less than equal to an by 2. But see here, there is two cases. Means I can write a 2an plus 1 is less than an. Means if we took limit both side, take limit both side. Here also limit n tends to infinity. As we studied, both are same limit. 2a should be less than equal to a. Means a should be less than equal to 0. But a can't be less than 0 because it will never decrease beyond 0. 0 is one of the lower bound. It can't go beyond 0. So a is equal to 0. So this is the limit of the sequence. Proved. Hope you get all the things what I explained. So we'll see in the next video. So till then, keep studying. Take care of yourself. Goodbye.